Hi children, this is the second video of the topic algorithms on graphs. From this topic we are going to discuss the Prim's algorithm. What is Prim's algorithm? Prim's algorithm is another method to find the minimum spanning tree. Hopefully you have understood what is the minimum spanning tree from our first videos. Let's try to understand what are the steps we have to follow up to obtain the Prim's algorithm to find the minimum spanning tree. Step 1. Choose any vertex and start the tree. This is one difference between Kruskal's algorithm and Prim's algorithm. In Kruskal's algorithm, we have started with the minimum weighted edge. But here there is no such preference. We can start with any vertex you prefer. Step 2. Connect the next vertex from the minimum edge. Now, from the point we have started, go around with all the edges connected to that vertex and see whether which edge contains the minimum weight. You have to follow up that edge and connect the next vertex through the minimum weighted edge. Step 3. Now you can understand, now you are connected more than one vertices. And those vertices are connected with different edges with different weights. Out of those weights, now see whether what is the next minimum weighted edge. Connect that edge. That is the step number 3. You have to follow up the sequence tentatively to identify the minimum spanning tree. Then we will come up to the step 4. When you are connecting such edges, you will realize that from certain edges, it continues up with some kind of cycles. You know that for a tree, you cannot obtain any kind of cycles. Therefore, in such connection, if you make any kind of a tree, omit that edge and repeat the step number 3. You have to follow up this sequence until you complete the minimum spanning tree. The short form of minimum spanning tree we call it as a MST. What are the differences between Prim's algorithm and Kruskal's algorithm? One difference I have already discussed. The first difference we can obtain is from Kruskal's algorithm we start from the minimum edge, but in Prim's algorithm there is no such preference. The second difference is Kruskal algorithm we follow up the sequence of ascending order, but in Kruskal's algorithm we don't see following up a such sequence. Let's try to apply Prim's algorithm to find the minimum spanning tree of the connection between there are 6 vertices A to F, and we are going to apply this Prim's algorithm to find the MST for this question. Now I am going to start from any vertex I like. So with this case I told you from the previous slide even there is no preference which vertex to be started. The reason is that at the end of the diagram we are connecting all the vertices. Therefore anyway the minimum whether you start from the vertex which is connected to the minimum edge or anything else, not, it doesn't make a significant difference. Therefore I'll start with A. Now let's move on. If you start with A, see whether what is the edge contains the minimum weight. So if you work out with this, you can understand that AF, which is with the weight of 8, is the minimum weighted edge. Therefore, I'll connect AF. Now you can understand that the two vertices A and F is connected. Then see whether out of the edges connected to A and F, what is the next edge with minimum weight. From this diagram you can understand that AD is having the next minimum weight. Therefore I will connect AD at the next extent. Now children, hopefully I think if you are having the initial diagram, is much easier for you to understand this question. Now when you come up to this stage, the vertices F, A and D are connected already. Now see whether out of the edges connected to vertices F, A and D, what would be the next edge you have to connect which is having the minimum weight. So if you refer to that, you can understand that the edge DC would be the next minimum weighted edge. Therefore, I'll connect D to C. Now the connected vertices are F, A, D and C. Now see whether out of the edges connected to vertices F, A, D and C, what would be the next minimum weighted arc. If you refer to that, you can understand that AB with weight 9 would be the next minimum weighted graph. Therefore, you can connect the edge with the HAB to the diagram. Now, for the moment, the vertices F, A, D, C and B are connected. Now, look into the arcs with minimum weights. If you refer with that, you will understand that the next minimum value is BC. But if you connect BC, it performs a cycle of AB, C and D. Therefore, you have to omit the arc BC and the next goes to AE. Therefore, I will connect the vertices A and E from the edge AE. Now you can see it has performed the entire minimum spanning tree with weight 45. Hopefully you have understood how to use the primes algorithm to find the minimum spanning tree for this question. Now we have to learn about how to apply primes algorithm on a distance matrix. If you do not have a clear idea about what is a distance matrix, please watch the videos referring to chapter number 2. Then as same way what you did in primes algorithm in graphical method, you have to start from any vertex you like in the distance matrix. Then from that specific vertex, draw a horizontal line and block that vertex. Thereafter, find out what is the minimum connection from that vertex to the next vertex. Then block those two lines. Then after that, identify what are the minimum values available in the two blocked lines, and you have to repeat the same steps, avoiding the cycles. But just looking at this theory contents, you may not understand the concept very clearly. Let's try to understand much clearly from an example. Let's try to use the primes algorithm to obtain the minimum spanning tree for this distance matrix. This distance matrix contains 5 vertices. I will start with vertex A. First, you have to block the line with vertex A. Now see whether in that line what is the minimum value obtained. The minimum value obtained is how much? It's 12. Then cycle that 12 and mark the cycle on AC on the line with C itself. Then you have adjoined the points or the vertices AC. Now as I mentioned in the theories, you have to block the line A as well as you have to block the line C as well. Now refer to the values available in the line, the block lines A and C. What is the next minimum value? You can understand that in the line A, the values are 27, 12, 23 and 74. 12 is already blocked. Therefore, the next minimum value is 23. In the line C, 47, 25 and 67. Therefore, you can understand that the next minimum value is 23 with D. Therefore, what we need to do is you have to circle the line 23 and mark a circle on D AD. Then after that you can understand that the next minimum value comes with AD. Then you can mark the diagram as A, C and D, and you have to block the line D as well. The next step, if you refer with the lines with A, C and D, the next minimum value occurrence is DB. Therefore, you can mark DB and you can add D into the diagram. Now you can understand that the lines A, B, C and D is already connected. Then after that, out of those edges, see whether what is the next minimum value. So if you refer to this diagram, you can see only the vertex E has to be connected to the diagram. Therefore, just look into the E is sufficient. But general concept, if you work out over here, you cannot connect any of these vertices, just like ABO, ACO, BAO, BCO, CBO, CDO, anything, because those lines are already blocked. Therefore, you cannot do it at the second time. Only the available point is to connect with BE of weight 71. Therefore, add BE to the diagram. It will complete your minimum spanning tree. Now you can see the minimum spanning tree ACDBE is already created with weight 21. Hopefully you have understood how to apply Prim's algorithm for a weighted graph, and hopefully enjoy this video and put a big like onto my video, and please subscribe my channel. Thank you.